Let me know once you guys are able to see the screen.
Yes, Varsha.
Once again. All right. Is it visible the full screen as well to everyone? Right. So, hi everyone. My name is Varsha Vidwani, and I'm working as a Splunk engineer in BitsIO for 4+ years. And in total, I have a Splunk experience of around uh, almost 9 years. And today, for this user group session, we are going to talk about the skipped searches in Splunk and how to fine tune the scheduler. So, basically, what are skipped searches? I'm not sure if you guys have if you have faced this issues in Splunk that your searches are getting skipped due to some reasons. So we will talk about that in today's session, and let's look into what are the skipped searches. The agenda would be we will be talking about what are the skipped searches and how do we view them in Splunk UI, anatomy of a skipped search, ways to tune the scheduler, and best practices. So skipped searches are one of the most common and impactful issues. They are basically when Splunk's scheduler cannot run a saved search within its defined time window. It would simply skip that particular run, and it will move forward to the next scheduled instance. It will not wait or pause. It will just proceed with the upcoming scheduled as defined. Now, when we also talk about the real-time scheduling and continuous scheduling, so by default, the setting is real-time scheduled. So what does that mean? That this is a very important difference. So in real-time scheduling, if a search run is skipped, it will never be retried for that particular run. It will never be for example, if a scheduled search is again. Yeah. Hi, Satyajit. So, when if a search, for example, is defined as a real-time scheduling, it will never be retried. That is, it is never gonna run that particular search again for that particular instance. For example, if you are running a search every minute, so if it is skipped in this particular minute, it will not be retried again for that minute. If it is skipped, it will be waiting for the next instance. So the next minute, for example, or every 5 minutes if it is running, so it will be trying it again in the next 5 minutes, in the later 5 minutes duration that it is scheduled for. So, or it will try to run, basically, it will also, since Splunk gives real-time searches higher priority, it attempts to run them as close to schedule as possible. But in case the system is really busy and the window is missed, then that particular run is considered gone permanently. So that is about the real-time scheduling. On the other hand, the continuous scheduling behaves like in a different way. If a search is skipped for any reason, maybe due to resource constraints or system load, Splunk will actually retry that search later. It won't be abandoning the search, but it will try to make sure that that the skipped run is still executes. So this is the difference between real-time scheduling versus the continuous scheduling. Um, Also, there are multiple, like they are causing multiple delays if there are skipped searches. Maybe for runs, some reason the search was never run, and it was skipped, it will cause delay in the output if you are posting the output to a particular URI, or if it is an alert, it will miss it out if the search is skipped. It can also prevent the apps from working as intended, and it can also impact the users' workflows. Next is the type of the skipped searches. So we have the first group, concurrency limits. So this basically means Splunk is already handling more searches than it can at that moment. When too many searches are running at the same time, Splunk won't start new ones. It will just skip them. Based on, we have different factors affecting those. We will discuss about that in the later slides. But yeah, in based on the concurrency limits, if too many searches are running, then it will just skip the new ones. Yeah, and these limits can apply at different levels. Like these can be applied across the entire cluster, or on a single search head, or let's say even specific to an individual saved search. Splunk also differentiates between things like saved searches, real-time searches, and accelerated searches when applying these limits. Next, we have the role-based reasons. So this is all about what the user is allowed to do. So every role in Splunk has a search quota, which limits how many searches a user can run at once. And it also have a disk quota that limits how much space that disk quota that will like basically impact how much space the search results and artifacts that are generated can take up. And of course, the permission also matters here. So if a user doesn't have access to run a particular saved search, the Splunk will skip it automatically. So this is role-based type. The lastly, we have the search related issues. So sometimes the search itself is a problem. Maybe it references a knowledge object like a lookup or field extraction or macro, which is not globally available. It is private, or for some reasons, it is not able to reference a knowledge object, which maybe it doesn't exist, or yeah, for these reasons. So it also can be a kind of skipped search. So yeah, it could also, for example, if the search is using a command that the user don't have access to, so that can also be one reason it is skipped. It could also be something as simple as the search string not being well formed. It is not valid. It is like some broken query. So in any of these cases, Splunk will just skip the searches instead of running those. So overall, the skipped searches happen when the system is overloaded, or the user isn't allowed to run the search, or the search itself is an issue. Now, how do we view the skip searches from the UI? So the first option, which is the easiest ways, is to look through the health report. So here, if we see, we have search scheduler, and we have an option here, searches skipped in the last 24 hours. It can look something like this. It is right in the navigation. So from there, we will be easily, like it is easily visible if there is any error. And no matter which page you are on the Splunk UI, like you are able to click on that icon and look at any kind of issues that are on your environment, and specifically the searches is skipped in the environment, and it will give you the root causes as well. It also has some, like these are some configurable thresholds that it is highlighting, like based on it, like it has 71% skipped ratio over the last 24 hours, and which is very high. So these are some configured threshold, and you can decide at what point Splunk should notify you about the skipped searches. These can be manually changed as well. For example, you might want to alert if even a few searches are skipped, or you might only care when it becomes a bigger pattern. So in both cases, you can do that, customize. And it is a great starting point. Like if we just click on the health report, whenever you want to investigate like what is the error about and why the searches are getting skipped, it will quickly give you an overview and help narrow down where the issue might be coming from. So, right. Um, Another place where we can look at the scheduled, where we can look at the skipped searches is the monitoring console. So from the settings, if we go to the monitoring console, this is like we can have it on cloud management console, or this is the cluster management console. So compared to the basic health report, this monitoring console will give you more deeper insights into what is going on. So if we go so from here, if we click on search, scheduler activity instance, currently like we don't have anything here, but yeah, how it will look in your environment if it is something bigger issue. Sorry. Yeah. Yeah. So it will give you a detailed statistics about of how many skipped searches were in total in the environment, what is the skip ratio, and the reasons as well. So and group by reasons. So this is really helpful. It in case um, you want to understand whether this is a sudden spike or an ongoing pattern. So we can change the time range, and based on it we can like analyze. And then there's the big breakdown of the reasons as well, which is basically telling you like why Splunk is skipping them, whether it is concurrency limits or some other reasons like role based or any problem in the search itself, like it is not well defined. So this is something really good to check periodically, just to keep an eye on the overall health of your saved searches. And if you're starting a troubleshooting session, like this monitoring console is one of the best places to begin with, of course, because it will give you much more detailed view than the previous option that we have seen, the standard health report. Lastly, like if we want to dig into like further details in the internal logs, the scheduler .log is where we will find the raw information. This log records like these files, the scheduler.log, or the source type is scheduler, like it will record each event individually. And you can, if you're basically trying to troubleshoot a very specific search, or if you want to understand exactly what is happening at a particular time, this is where we can look into the internal logs. It will give you a granular level of detail, and it will also give you the reason why the search was skipped and what the scheduler was doing at that particular time. So any error messages or constraints that were triggered. So it is not something that you can check like casually, but if you have a stubborn issue, for example, then definitely the start point is we look into the internal logs, and there we have everything. All right, so next is like we are going to talk about like how the Splunk scheduler works. So like what is happening inside the scheduler, how it works behind the scenes. So here, for example, the scheduler operates on a 1 minute cycle. Every minute, it goes through the same sequence of steps. These are the same steps that it will continuously repeat. First, it will load the full list of searches that are eligible to run at the moment. So in the savesearches.conf, we have the saved searches defined, which are enabled, at what cron schedule they have to be run. Once it has the list, like it is loading, and then it will randomize the order. For example, like what it will do is it will shuffle, prioritize, and sort. It will, why it is randomly selecting anything, because to make sure that searches are not unfairly prioritized just because they were defined earlier in the config file. So SS0 just because it is defined first doesn't necessarily like it has to be, executed first only in order. No. So this is how Splunk will shuffle and prioritize and sort. After that, Splunk will calculate the priority. If there is any priority associated with these searches, it will look into that. And if not, it will calculate the priority. And this priority is influenced by factors like whether this is real time or scheduled, or it is an accelerated search, or even if the role of the user is higher. So just give me a minute. Okay. All right. So then after it has decided the priority, it will sort all the searches based on those priority values. From there, the scheduler still like it will start trying to dispatch the searches in those that manner defined, that priority order, but it can only dispatch as many searches as the system's concurrency limits allow. So there is a concurrency limit that we have, like we will be setting, or based on the number of cores that you have, it will give you. Splunk will be defining the concurrency limit, and like as in it is there, and based on that concurrency limit, we will Splunk will be dispatching the searches as many as possible. Like if it is 10, if the concurrency limit is 10 based on the resources, you're only allowed to run 10 searches at a time at any instance. And so what would happen is like everything is already busy, the concurrency limit is reached, or lower priority, then what would happen is like lower priority searches may have to wait, or they will be skipped in that case. Now, if we still have searches left in the queue, it will not stop. The scheduler will not stop until the next minute begins. So it will try to continue like dispatching those searches. For example, if we have around 10 searches to run in a particular minute, it will try to execute as many as possible until it reaches the end of that minute. It will give like what would happen in that case, this gives extra opportunities to run searches if resources free up before the next cycle starts, before this whole cycle starts again. So overall, what is happening? The scheduler checks every minute, prioritizes everything, tries to run as many searches as possible, and keeps trying every second until it resets for the next minute. So let's go through this example. So for example, these are the saved searches, and this is the schedule time. It has to be run every minute. So what would the scheduler do is it will try to run as many searches possible and more frequently, right? So here we have the prioritized view, like they have for every like this has to be run every minute. These saved searches, saved searches has to be run every minute. And on the right hand side here, we are looking at the scheduler concurrency over time, which will help us understand how busy the scheduler is and whether it is hitting the limits. So at time zero, what happened is like all at time zero, that is every second, for example, first second, these all searches are eligible to run. Now, a scheduler, what it will do is it will look at the list and pick as many searches as possible based on the concurrency limit. So we have concurrency limit of 5 here. So we have 5 slots. What it would do is it will start with the 5. Let's assume it will start with the first 5 searches. So first 5 searches it has started with. In the next search, in the next second, like at T1, if there is any search that has already been completed, so it will pick a new one. So here it had 4 searches remaining, but now we can see that SS1, the saved search 1, has been completed, like it has been executed, and it will start the other fifth search from the prioritized queue, and it will run it. Similarly, like in the next second, if there are no additional searches that are finishing up, then nothing new will get dispatched. This will continue second by second. And for example, here in the T3, we have completed the SS3 and the next SS6 was started. So we still have two remaining. But if we see, like, let's say the priority, if the slots are done, like we had 5 concurrency limit, and this will be running, keeping on running for the next 60 seconds, like next 59 seconds, and we still have those two searches. So the counter will reset at the 60th second, like in the next cycle, it will reset, and the searches which are left will be skipped. Since we have reached the boundary of the 1 minute window here, all of these searches that were supposed to be completed within that 60-second schedule, by the time we have hit 59, T59, only 7 searches were completed, and 7 and 8, the other 2 searches have been skipped in that case. These are unfinished searches, and because the scheduled window has passed, these are now considered by Splunk as skipped searches. And now Splunk scheduler will move on to the next cycle, and those missed runs will not be executed. So we will not be executing this SS7 and SS8 in the next minute. It will be like restarted. All right, so moving on to the next slide. Hope that was clear to all. We will take questions at the end of the session. Yeah. Now, let's look at the different factors that are actually contributing to the skipped searches. The first factor is the search runtime. When searches take longer to complete, they hold on to a concurrency slots for a longer period, right? So, which means other scheduled searches don't get a chance to run. And eventually, some of them end up getting skipped simply because the system was too busy. So we have seen, like in the previous example here, SS0 was taking a lot of time, and SS5, SS2, these were taking a lot of time and were running till the end of the very minute. So this is the reason also that other searches were skipped, right? So if the search run time is really longer, it can be leading to the skipped searches. Second factor is the distribution of searches. So if too many searches are stacked on the same schedule, like all running at the top of the hour, which we generally do, or every minute, if we are running them, these are scheduled to run every minute, the scheduler gets overloaded all at once. So the total number of searches also matters. The more you have, the harder it becomes for Splunk to keep up during peak times. Next is the frequency of searches. So the searches that are running very frequently, every few seconds or every few minutes, they consume more scheduler resources over time. If we have too many high frequency searches, like running too many times, they start to crowd out the lower frequencies ones, which increases the chances of skips. And finally, the search concurrency. So this refers to like how much of your total concurrency is actually allocated to a scheduler. If a lot of concurrency is being used by ad hoc searches or user-driven searches, queries, then the scheduler gets fewer slots. And with fewer slots remaining, scheduled searches are more likely to be skipped. So, like overall, skip searches happen when they run too long, or too many searches are running frequently, or if there is not enough concurrency available for the scheduler to do its job, right? Now, let's talk about how do we fix it, like how do we tune the scheduler. Now, what if users are stacking scheduled searches at common cron schedule? We would generally run searches saved. We will schedule them to run at like maybe every 5 minutes, every 10 minutes, or they are running at top of the hour. Like usually we do that, right? Like until we have some issues with the we actually have a problem, we will not fix those. We will be generally like running them every 5 minutes, 10 minutes, and so on. When too many searches are like fired at the same exact moment, a scheduler will again get overloaded, and that's when we start seeing spikes in the skipped searches. One of the best way to fix it is by using something called allow skew. So not sure if anyone has already used it, but this is a very good option to fine tune the scheduler. So it is basically telling Splunk that don't run this search at the exact scheduled moment. You can spread it out a little, right? You can spread that search out a little, and this will simply change bring uh, this will basically this will bring many benefits. It will reduce the concurrent load. It will lower the chances of skipping, and why? Because we are spreading it out, and we are not hammering the scheduler all at once. And by default, like Splunk uses already this option for many scheduled searches. You can disable it for a search absolutely which needs to run at the exact moment or precise time. For example, if you are running a scheduled search for a compliance report or any SLA specific searches are running. So if you want it to run at a precise time, then you can disable that option. Um, this can be configured again in two ways. Either you can specify the percentage, like 50%, which would mean that scheduler is allowed to shift the search up to 50% of the scheduled interval. Sorry. So that is one way. Another way, you can give a duration like 30 seconds, 2 minutes, 10 minutes, which would mean Splunk can randomly distribute the search within that duration. So what this does behind the scene is let the scheduler randomly spread out all the searches, making the workload much smoother and significantly improving the reliability. Let's look at this another example where we are using the allow skew. So for example, we have now given we have defined a specific duration that it can be moved to a minute. This can be very precise, like we don't have to we cannot spread this search out. This has to be very precise. Then these others can be kind of spread out, like we can it is fine if a Splunk runs those within a period or within like 3 or 4 minutes or 5 minutes late is fine. So what would happen in that case is, since the T0 we don't have, for SS1 we don't have any skew defined, we have disabled it, so it has to be run at the exact moment. Next we will be beginning the next scheduler will start executing the SS0. Again, it will pick up the SS3. Meanwhile, if SS1 is already completed, that is well and good. For T3, like T0 plus 3, we have like SS2. So Splunk will start executing that. And lastly, then at the fourth second, it will pick up the SS4. So it has, we can also see that it has freed up like here. Using this option, it will be like very beneficial in improving the performance. It will smooth, like the scheduler job will be like very smoothly running. So this first option is really helpful in tuning the scheduler. Another option that we have is to configure the schedule priority in the savesearches.conf. Now, sometimes not all searches are created equally. So you might have certain reports or correlation searches that are critical, that are data that are tied up to the compliance, billing, or high priority security alerts. In those cases, what we do is we don't want to we don't want them competing with all other searches. We will just schedule those with some priority, and that is like you will want Splunk to treat them as the more important than the other searches. So that is where we can configure this option schedule priority. This setting will allow you to elevate the priority of a specific searches so that a scheduler picks it up before other searches. This will boost their priority, and we will significantly reduce the chance that these critical searches can be skipped or will ever be skipped since they are higher priority, right? Even when the system is under load, like there are very rare chances that these get skipped. We either define the scheduler priority as default, selected by Splunk. It can execute it as at any time, like if there is any other priority. So accordingly, it will schedule that higher or highest. For default, like it will behave normally. But if you have set it to higher or highest, Splunk moves that search up in the queue during scheduling and making it like much more likely to run on time without getting that particular search skipped. So this option again, schedule priority is really useful when you need to guarantee that certain searches like get the scheduler's attention before everything else. Here, for example, you can see each colored block corresponds to the priority assigned for that search type at a given point in time or resource allocation. For example, this RTSS, mostly the search has default and mostly default and higher priorities, but one slot is marked as highest, this one. AS, for example, has a higher and highest priority early in the timeline, indicating that this is critical. So basically, by adjusting these schedule priority, admins can control which searches should execute first when multiple searches compete for resources. And yeah, it can again like prevent the critical searches from being delayed and ensures the efficient use of system resources. Next option is the schedule window. So again, like not all searches need to be executed at the top of the hour. We can allow like less critical searches to run later. So high priority searches can take precedence. That is a question. Like, so what we can do is the scheduler can be tuned in that case to prioritize searches based on importance and timing flexibility. How it works is like for searches that are that can tolerate variations in their start time, we can configure the scheduler to delay them slightly. This is controlled by this setting schedule window. This parameter, when it is set to non-zero value or auto, it signals that search does not require a precise start time, schedule window. So yeah. What it will do is scheduler will use this flexibility to prioritize other searches that needs to be run immediately in case we have defined that this one is not to be prioritized in this case. So system will automatically calculate an optimal window based on the historic run times for these searches. One more point to add. So searches with very infrequent schedules may experience longer delays if their schedule window is set too broadly. So we need to take care of that. And we will be then as a best practice, like if we are using schedule window, it will like effectively helps the scheduler balance system load and ensures that critical searches are not delayed, while less time sensitive searches still gets executed efficiently in this case. Next option is the max searches percentage, which is set in the limits.conf. So this setting controls what percentage of the system's total search concurrency is allocated specifically for the scheduled searches. By default, we have like 50%, meaning only half of the available search slots can be used by the scheduled searches. The remaining are kept free for accelerated searches, ad hoc searches, ensuring that users running manual queries don't experience slowdowns. One of the advantages of this particular setting is that this can be adjusted dynamically. For example, during off hours, like late at night, you can increase this percentage to allow more scheduled reports and alerts to run without competing with interactive user activity, depending on the business hours. So here we have setting max searches percentage integer, which simply defines a percentage of the total search slots reserved for scheduled searches. Again, the default value is 50. Splunk will also be allowing the time-based overrides using these two settings. So this lets you specify different values and different time at different times. For example, one value during the business hours and other value during the weekends. You can put it here, like when these two settings can be defined. The scheduler will check this cron schedule, the string here, and if it matches the current time, it applies to that specific setting. If it is for weekend or if it is for odd hours, like off non-business hours, it can apply that particular setting here. Like 50% can be changed to a particular, let's say 80% during non-business hours, right? Overall, this configuration also gives us a very fine-grained control over how Splunk balances concurrency between the scheduled workloads and interactive usage. This also helps ensuring performance is optimized throughout the day. Last option is like workloads, like not last, but this is another option, which is like workloads underscore rules.conf file. We have a setting known as ad hoc search percentage. And here we will shift our focus towards controlling the ad hoc searches. So which are the searches like triggered directly by users from dashboard or any manual query activity. So what it will do is it will allow us to limit how much of the total concurrent search capacity can be consumed by the ad hoc searches, right? So the idea basically is to ensure that interactive user activity does not overwhelm the system. So sometimes like users are troubleshooting something, they are executing a lot of queries, rewriting the SPLs. So this interactive user activity sometimes can overload the system, and especially during peak load times when scheduled searches like alerts, reports, or accelerated searches must run reliably. So there are two important notes here, concepts here. So limiting the concurrent ad hoc searches by assigning a percentage value, we can tell Splunk that only allow like the ad hoc searches to use this much portion of the total concurrency. If they reach the limit, start filtering or queuing them. Okay, and what would happen is like this will help prevent situations where user-driven activity unintentionally starves the scheduler. The second is the protecting scheduler from user activity. So schedule searches are critical for alerting, compliance, and reporting. By capping those ad hoc search usage, we ensure that the scheduled searches always have the necessary resources to start on time, and they are not getting skipped in that case. So like how we do is like on here, each rule is defined under a search filter rule stanza. And inside the rule, you specify a predicate which tells Splunk what searches this rule should apply to. In the string format, you have to mention that. For ad hoc search percentage rules, the predicate must include a search type as ad hoc. You have to mention that search type as ad hoc in this stanza. And in this way, we are just telling that only the ad hoc searches are controlled. The value itself is an integer between 0 to 100, and it represents the maximum percentage of concurrent search slots ad hoc searches are allowed to consume. Basically, to summarize, ad hoc search percentage here will give you a safety mechanism to manage the user initiated searches, uh, manage the workload by the user ad hoc searches, and ensure that the scheduler remains stable, predictable, and capable of running all the required scheduled tasks without delays. Now, best practices. So, what are the best practices to reduce or completely avoid? How can we completely avoid those skipped search ratio or search skipping from from the scheduler side? So first, if the searches tend to run slowly, we can schedule them as infrequently as we realistically can. This will cut down the overall load on the scheduler, and it will also free up some bandwidth for the most important or critical searches. Second, if we are seeing any sudden spikes in search activity, we can enable the allows queue, which will help distribute that load even more evenly, and it will prevent large burst or help in reducing the contention around popular cron schedules. Like we are very commonly we can use every 5 minutes, or if at 2:15 p.m. or a.m. or 6 o'clock in the evening, some things like that. So next is for critical searches that you absolutely cannot afford to skip, make sure that they are properly prioritized using the schedule window as auto, and applying those priority settings ensures that these jobs get the resources they need. And finally, if we are consistently running into scheduler capacity issues, consider tuning the scheduler itself, giving it more bandwidth when ad hoc search volume is lower, and protecting with the um, rules which will help maintain smooth operations. So, to wrap things up, the key takeaways that skipped searches are usually a symptom of the scheduler pressure, but they can again be managed and prevented. We can start by understanding what the skip ratio looks like in the environment. Once we know the scale of the issue, we can investigate the root causes via different uh, reasons the Splunk will give you in the internal logs or the monitoring console. It will tell us whether these are slow searches, load spikes, or misprioritization, or simply like the scheduler capacity limits. Then we can apply those best practices we discussed today, scheduling searches more efficiently, spreading out the load, prioritizing the critical searches, and tuning the scheduler capacity. With these steps in place, you can significantly reduce or even eliminate search skipping and ensure that the Splunk deployment is running reliably and efficiently. So thank you. And now if there are any questions, please let us know. Um, so I think it's all clear to everyone. So thank you for joining. If in case anyone wants to still add anything, let me know. Or if anyone has further inputs, they have used these options, um, then yeah, you're happy to share those thoughts. Otherwise, we can. Right, let's see what question do we have.